like to welcome you all to Google, to our Go Meetup here. My talk is going to be about supply chain security with Go. And to give you a better idea of what we'll cover, first we're going to start by how you keep your Go build environment up to date. Then we're going to, now that we have the foundation laid, then we're going to look at the program specifically, like is your program vulnerable? In these two first parts, we're going to use a lot of Go modules. So then we're going to look at, are Go modules actually trustworthy? And then I'm going to switch gears a little bit and talk more broadly about a couple of best practices like separation, least privilege, sandboxing, and so on. And lastly, you've already heard the name in the previous talk. I'm going to show you an example of what I call supply chain minimalism, which is my Gokrazy project. So the context or the lens of this talk is that you become aware of a security vulnerability, and the question is, what now? And the talk tries to answer that question for a number of common scenarios. So let's start with part one. So to set the scene, you're either like maybe a developer or an admin or in some other function. It doesn't really matter. All that matters is you're responsible for running a Go program. Furthermore, in this talk, I'm going to assume that we're all using Go modules. They have been introduced in Go 1.11 in 2018, so I really hope that by now you've all heard of them and had a chance to migrate your stuff. This means that we will have a go.mod file. I assume you've heard of go.mod, but if you don't have one, you use go mod init to create one, and whenever you make changes to your code, you can use go mod tidy to clean up the file. It kind of looks like this on the slide, where you just have like the name of the module and then all of the requirements, so all of the dependencies that your code uses. Okay, let's start with a really basic question. Is my build environment up to date? So how would you do it? Well, you just open a terminal, enter Go version, and it will print you something like this. In my case, when I prepared the slides on this laptop, I was on Go 1.22.0 running on a Mac. Then you open your browser, you go to go.dev/dl, and you compare. And in this case, I could see actually there is a newer version available, 1.22.2. So I should probably update. The first question you might ask is, can you actually use the latest toolchain? And the mental model of the Go team is that the latest Go version, such as 1.22.2, is always the best implementation of a certain Go language version and also the ones before it. Right? But what if your program was actually developed for an older Go version? The good news is that Go 1.21, so the second to latest release, improved both backward and forward compatibility. What do I mean by that? When I talk about backward compatibility, I'm speaking about a concept called Go debug. Don't get hung up on the name. It was first introduced as sort of a debugging aid, but it has now become more general. In fact, all of the changes that could risk breaking programs are tied to such a Go debug setting. So I hope you all know that if you're using certificates, SHA-1 is a broken algorithm, so you shouldn't be using it, is known insecure. However, if you really have to, you can still make Go programs work with the X509 SHA-1 package by setting the environment variable go debug equals X509 SHA-1 equals 1. Right? That's how you would do it. The default value for these Go debug knobs are tied to the go.mod language version line. So as another example, in Go 1.22, we introduced go types alias equals 0, and in 1.23, the value will change to go types alias equals 1. Why did we introduce it with the default value of 0? So that people have time to check their programs, to run them with go types alias equals 1, see if anything breaks, make adjustments, and then be ready by the time the release comes out. These Go debug knobs are maintained for at least 4 versions of Go, meaning a time span of 2 years. So you should have plenty of time to do sort of, compatibility adjustments. If you want to learn more about this mechanism, I've put a link to the Go blog here at go.dev/blog/compat. I'm also going to share the slides later with you, so you don't need to type this into your mobile phone. In general, there's a lot of good stuff on the blog, and I'm going to refer to it frequently. So let's look at the other direction, forward compatibility. What if you want to build with a newer Go toolchain? So Go 1.21 was an important release. It came out in August 2023, and it shipped toolchain management. So that means that a main module can now actually require not only a minimum language version, but also a minimum toolchain version. For example, if your program turns out to depend on a specific fix. So for example, in Go 122.2, there was an HTTP-related security fix. And if it turns out that my program needs that, it would be good to say go mod edit -toolchain Go 122.2, so that anyone who builds the program will be on at least 122.2. You can see this in action here. When I use the go install command on, for example, the scan to drive project, it prints this one line here saying it's now downloading 122.2 for me, because as I mentioned earlier on my laptop, it was still 120.0, right? So once I set the requirement, it will do it all automatically. And before you say, wait a second, it downloads like a new toolchain, I don't want that. Of course, you can opt out of this. You can set the go toolchain environment variable. You would typically do this, for example, in a Linux distribution where you need like more specific control over your toolchain version. But personally, I find that it is so convenient to just let the Go tool manage my toolchains as well, that I'm using this mechanism as my primary mechanism for version management. So then the obvious follow-up question is, well, can you actually trust these toolchains? What's inside? What are you installing on my computer? And the good news here is that starting with Go 121, the toolchain is perfectly reproducible. So that means that we built a toolchain without cgo to remove any host dependencies. We built it with the -trim path flag enabled so that the directory path in which you build Go doesn't leak into the actual executables. And there's a couple of other smaller changes like that that have happened. And now Go 121 and newer are perfectly reproducible. You can find details about what that means at go.dev/blog/rebuild. And in fact, there are daily reports at go.dev/rebuild where you can just check out that it all still works. I want to point out that in the rebuild blog post, which Russ Cox wrote and published, he is actually verifying that the toolchain that is shipped by Ubuntu in its latest version matches the toolchain as shipped by the Go project upstream. And he does that verification on a Mac, so he's not even using Ubuntu, right? So that's how far you can go. You can really like look at all of the bits and put them into place. It's like nicely independent and clean. If you want to learn more about toolchain management in general, go.dev/blog/toolchain. All right, so to recap what we talked about, we have a go.mod file. You all know it starts with the module and then the module name directive. You have probably seen the Go language version in there, so that would be like Go 121. And now you know that you can also specify a minimum toolchain version, but that is optional. You don't need to have it in there if you don't have any special requirements. Okay, so where can you get informed about a new release? You don't want to check your installation every day. Instead, you can subscribe to the Golang Announce mailing list. And you can also just put an entry in your calendar because you know that Go is released in February and in August of each year. So that's very predictable. What isn't predictable is whenever security issues are found and we need to make a security release. However, there are pre-announcements for each security fix that go out 3 to 7 days before the actual fix release, so that you have some time to like start internal processes, get approvals, resources, preparation, whatever it is you need to do, but at least you'll have a nice heads up about it. All right, so now we have the basics covered. We know how to build Go code, we know how to keep our toolchain up to date, and so on. Let's switch gears and look at a specific program. To answer the question of whether your program is vulnerable, I think we first need to sort of establish what your program actually is. And I mean, if you're the developer, that's clear, right? It's whatever you built, no question about it. But in other roles, such as maybe a sysadmin, you don't necessarily have that much of a handle as to what is running in production. And what I really like about Go is that since 1.18, which was released in March 2022, so by now this is in Debian stable, so this is very widespread overall, you can just use the go version command with the -m flag on any binary that you have. So you could log into a production server using SSH and just grab that binary, run go version, and you'll get an output like this on the slide. And it shows you not just what the module name was and the path of the specific binary within the module that you've built and all of the dependencies and stuff, but it also includes the build info. And the build info shows you that in this particular case, this program was built from Git at revision 7E8A and so on, right? which corresponds to a commit at the 7th of March in 2023. And the vcs.modified directive is also important because it tells me that there were no local changes in that git checkout. So with this information, I can actually go to the source code repository, check out this revision, and build exactly the same binary again. And then I can be confident that now I'm in a position to actually change what's running in production without doing any unintended changes aside from the security fix I'm about to push, right? So the build info gives us a chance to locate the corresponding source, and having the source is important, not just so that you can make changes, but also because we have a very powerful tool, which is called Go Vulncheck, which compared to other vulnerability checkers doesn't only use binary analysis, it actually does static analysis on the source code level in order to reduce spurious reports, because it then can actually look at, when there is a vulnerable dependency of yours, are you actually calling into the part of the dependency that is vulnerable? And you can install Go Vulncheck using the go install command I've put on the slide here, and then you just run it on your source code. You can also check out the vulnerability database entries in your browser. I've linked here the Gorilla Sessions report, if some of you might remember that when it came out. It was one of the more memorable Go security issues in recent memory, I think. In fact, I had a program that was actually using that package, so I was very curious to learn if it was vulnerable or not. The way I could do it is I could just run go vulncheck, and then the // is sort of like a regular expression matching all of the files underneath the current directory. And then what Go Vulncheck does is it queries the Go vulnerability database, and it does that live. So there's no like cache or update propagation time or anything like that. It really queries the vulnerability database as it is right now. And then it looks at your code. And here we can see that it reported one vulnerability. It is the directory traversal in Gorilla/sessions. And it also prints me an example trace of where my program is calling into that. So I can see that in internal web UI, I am in fact calling the file system store.get. It turns out that this vulnerability wasn't actually a vulnerability, but everyone thought so at the beginning because there was like a blog post that outlined how somebody hacked like a firewall vendor appliance that was using this package, but it turns out that the bug was actually in the user code, not in the library. Oh well. So this report was actually retracted later on, so if you run Go Vulncheck now on the same code, it will actually not show you anything because it was actually a false positive, but it took the community like a day or two to realize this. All right, so let's assume though that the code is vulnerable. What can we do to mitigate this vulnerability? The first and easiest way, of course, is updating. We can just update to a fixed version of our dependency, but that also means that we need to have a fixed version available. We're going to talk about what we do if we don't. An important thing to note here is that this update is only needed in the main module of your program. In other languages, sometimes people, if they want to like remove a vulnerable module from the dependency closure, they go there and go through all of the dependencies and their dependencies and then look at all of the dependencies and remove the vulnerable code from all of them. Right? And sometimes I get pull requests of like, yeah, change this here and so on, and then I can just tell them, look, you don't need to do this in Go. Because in Go, we use what's called minimum version selection, which means that the main module's version requirements effectively override your dependencies version requirements. If you want to learn more about why we use this algorithm, how it works in detail, and so on, you can go to Russ's blog at research.switch.com/vgomvs for minimum version selection. All right, so let's assume that there isn't a newer version available. Maybe the maintainer is on vacation as the security issue was released. What do you do? Well, you could patch it yourself, maybe. So you can create a writable working copy of your dependency by just cloning the Git repository as you're all used to, and then you use a replace directive in your go.mod file so that you can tell the Go toolchain, hey, instead of going to your module cache or fetching this module from the internet, just take it from my disk in this location, right? And then you just modify the source code and make your changes. And then to verify that your binary actually picked up the changes that you just made, I recommend you use the go version command again. This time, we can see that in the list of dependencies, I have one dependency, the AirScan module, which I've replaced with a locally patched version. And you can see that Go has actually included the full path of my locally patched version, and also the little devel in parentheses at the end here. And then lastly, if there isn't a newer version and you don't really know how to patch the security issue, the pretty much only option you have is to either stop your service, stop your business if it's not so important, but if it is important, maybe you just need to remove that dependency, right? So you would just open your editor, comment out the code, and then in order to verify that you've actually removed all traces of that dependency, a simple thing you can do is just run go mod tidy and see if the dependency disappears from go.mod. If not, you still have some reference somewhere. In this context, I also want to make a plug for easy and fast rollouts, because that also means you'll have easy and fast mitigation of security issues. In my case, I just have, for my hobby projects, I just have like a deploy all shell script. And if you've ever talked to me, you know that I hate shell with a passion. This is the only shell that I can just about stomach. It just like changes a directory and runs make. I think that's sort of acceptable. Anything else is too complicated. But then, so I just have like a list of all of the Go programs that I run on my servers. I just change into all of them one by one and just run make push. And the push target in the make file I've defined like on the bottom of the slide here. So a relatively simple pipeline of just 3 commands: a go build command, an rsync command, and an ssh command. The go build one is relatively straightforward. You just tell it where to write the program to. You can see that some of the flags that I talked about earlier for the toolchain are here as well. So we're turning off cgo to remove host dependencies. We're running with -trim path so that our working directory doesn't leak into the binary. And that makes the resulting program perfectly reproducible, right? And I really like that property for anything that I push to production, because then I can be sure of what I'm running there. The other environment variables just tell the go command, hey, I'm building for Linux AMD64, regardless of the machine that I'm building on. So it might be on a Mac or on a Windows computer or whatever. And then once the go build has finished, I'm just using rsync to synchronize this binary and all of the other binaries I might have to my server efficiently. And then lastly, I'm logging in, just restarting the systemd service file. This is pretty straightforward, but what I'm trying to say here is that a Go deployment setup doesn't need to be much more complicated than this. And this runs in like seconds, right? So I can just, build a Go program within seconds. I can rsync it very quickly, restart it, done. And when I see all the sort of complexity and more complicated CI/CD setups and rollout systems, I'm like, oh, that costs so much time, right? And it could be so fast. So I think it's a valuable exercise to sort of go back to the basics of how to roll out. And if anything takes much longer than this, you could probably optimize it. All right, so we've talked a lot about Go modules. Let's talk about trusting Go modules. One important property to note is that Go modules are always safe to download. So the Go tool intentionally, by design, never runs code when you download a module, because it could be untrusted. The obvious follow-up question is, well, but how do you then have sort of dynamic generation as part of the build process and these sorts of steps? And the answer is you don't. This is up to the module author. So the module author needs to run go generate or any other way to like run their generation step. And then they just submit the resulting code to Git, because that's all that the Go tool knows how to work with, code, right? It only downloads code, it never runs programs. Notably, also, when I talk about code, Go modules are always generated from source. So there's not like a maintainer step where you need to create a tarball where you might, I don't know, inject a vulnerability into the tarball, hypothetically speaking, right? It doesn't happen in Go, because that's not how the Go modules work, right? They just fetch the source code from Git, and that's all there is to it. You can read at go.dev/ref/mod much more detail about the modules. The modules alone are nice, but there's another important part of the module ecosystem, which is the Go module proxy. And important from a security perspective is that once you publish a module version, which means that once the first user has actually asked the proxy to give that module out, serve that module, it is immutable in the Go module proxy. So you can never have like an update to the same version of your source code. When you want to push changes, you need to also change the version, right? The Go module proxy is enabled by default if you install the toolchain from go.dev. There are some Linux distributions that disable the proxy by default. I think Fedora was one of the distributions that did that. I'm not sure if they still do. I don't like disabling the proxy because it makes everything so much slower. Because that means that the Go tool now needs to fetch all of these modules from their respective upstream repositories, and that just takes a lot more time than connecting to a proxy that already has everything in cache. I'm speculating that some people might disable the proxy because of privacy concerns. Personally, I think the privacy policy you can find at proxy.golang.org/privacy is very clear and totally acceptable. But if you're working with private modules where you don't even want the name of the module to leak to any sort of infrastructure, you can set the Go private environment variable, and then it will not even hit the proxy for that. But you can still use the proxy for like public stuff. So that would be my recommended setup. Or even better, you could run your own company internal or organization internal proxy, and then you get the benefit of like organizational privacy plus also the fast downloads, right? That would be even better. When we talk about the proxy, another important part that we should mention is the Go checksum database, or more broadly speaking, the go.sum file. So there's a go.mod file and a go.sum file. And the go.sum file stores a cryptographic hash of the module content, so of all of the sources, on first use. So this is sort of like a trust on first use concept, kind of like you're used to with SSH. When you SSH into a server, the first time it asks you, look, this is the hash, do you trust it? And then once you save it, it mustn't change. Otherwise, you will be notified that it changed. It's the same thing here. The Go tool verifies later, whenever it needs to download a module, that the hash of the contents that it just downloaded match what is in the go.sum file. So that means that your working copy of your main program is actually authoritative, right? So I could like put it on a USB stick and then transfer it to a country where I don't trust the infrastructure or an environment, right? And I can be sure that either the Go tool downloads the exact same versions of the code or it will complain and not build, right? And so this is the go.sum file within like a specific program, like on your disk. But the Go tool goes one step further, and it actually stores all of these checksums also centrally in a verifiable way. So this uses a transparency log kind of mechanism, kind of like TLS certificates, if you're familiar with that. And the interesting part here is that this design, where the Go tool has a built-in trust link to the Go checksum database, and all of the proxies also proxy the checksum database, means that you can safely use an otherwise untrusted proxy. So if some of you were to like spin up a proxy and tell me, look, this is the greatest, latest, newest proxy, please use this, I could totally use it, even if I don't trust you, because I know that the Go tool will verify the checksums. If you want to learn more about this mechanism, go to go.dev/blog/module-mirror-launch. All right, so now we've looked at a couple of infrastructure pieces. Let's talk more broadly. What can you do? Like, we are all aware of the reality. Even if we have like the best hygiene, sometimes there might be vulnerable code coming into our dependencies. And one thing we can do is separation. We could split out untrusted clusters of dependencies into their own process, or into a separate container, or a separate VM, or a machine, data center, continent. You can go as far as you want, right? But think about sort of which parts of your transitive closure do you really trust, and which ones do you trust less, and then think about whether you can establish a boundary between them. So for example, hypothetically, if I had a program, a server program that also did QR code generation as part of one of the handlers that it serves, I could say, okay, I don't really know much about QR code generation, don't really trust them, I can't write it myself. Okay, I'm just going to accept using a QR code module, but I'm going to move all of that logic into a separate process that I'm calling as in sort of like a microservice-like design, right? And then if the module authors of the QR code module, for some reason, insert malicious code, then they can still not run arbitrary code in my main process. They can only exploit the QR code generation part. Similarly, another best practice is to use the principle of least privilege. Like more, generally speaking, that means that if you run different services, you should run them each under a dedicated user account. Don't run everything as root or any other shared user, even if it's convenient. Resist the temptation, set it up properly, and split it out. If you want to go one step further, you can also enable sandboxing, which is super easy these days if you're using systemd to deploy your programs. You can use system call filtering with seccomp just by turning on an option in systemd. There is even, in fact, a nice little command which is called systemd analyze security, and then you can point that to your service file, and it will give you like a long checklist of, hey, this setting is not on its strictest value, and maybe that's actually risky, so you should change it. I have provided an example hardened systemd service file for a typical Go service that uses NetHTTP to just serve a couple of web pages, and you can find it at this URL. As I said, I'm going to share the slides later. And then lastly, immutability is also always a good practice. The more restricted your program is, the less havoc they can wreak on your system. So make as much as possible immutable and read-only. Again, if you're deploying with systemd, there's a nice little setting for it called protect system equals strict, and then most of the files on the system will not be able to be modified by your server. All right, so now with all of that out of the way, maybe let's change mindset a little bit and talk about supply chain minimalism. And for this, I want to present the Gokrazy appliance platform. So this is a from-scratch appliance platform that I created entirely in Go. This is important because of the supply chain security perspective, right? If you think about it, there are only 4 parts that go into your appliance if you use Gokrazy to build it. We will need to use a Linux kernel so that we have something to boot up your machine. Maybe there's some firmware involved, like on a Raspberry Pi, you need some binary blobs to bring it up. If you're on a PC, you can just use a standard UEFI, that's fine. Then we have the Gokrazy Go userland, which is like a minimal NTP and DHCP client, like just enough to bring up the network. And then you have your application. So this could be something like EVCC for your solar panels or other examples. I'm going to give you a nice little use case example in just a second. But the important part to note is that on a system that is using Gokrazy, there is no C userland or even runtime environment. So there's no glibc, there's no OpenSSL, there's no OpenSSH with remote vulnerabilities, there's no XC, you know, all of that stuff is just missing, and that can be very freeing and nice. In terms of how you would get started using Gokrazy, it's super simple these days. You can use the Gok CLI. If you used Gok new, it will create you a new config file. It's ready to go. You can immediately run Gok override, put in an SD card, overwrite the SD card, put it into a Pi, and boot it up, and there you go. I've linked gokrazy.org/quickstart. If you want to watch a video of this in action or try it out, feel free. The obvious question is, okay, that's nice. Like, I believe you can build such a system, but how far will that actually get you? Is it any good? And there is a surprising number of use cases that you can actually totally build with the system. One of them I want to present here is remotely triggering wake on LAN. Maybe you have a computer running at home that you sometimes want to access while you're maybe here at a meetup or on the road or whatever, but you don't want to leave it running all the time because it drains your precious solar-powered batteries. So you suspend it, right, to RAM, and then you also want to wake it up when you actually need to access it. In order to wake it up, you need to send a magic packet, and that packet needs to be in the local network. Otherwise, it just doesn't work, right? So you need to have a device that is running anyway in your local network. And for this, I think the Raspberry Pi Zero 2W is a great option. It's this super tiny computer you can see here on the slide. It runs at less than or at about 1 watt of power, which is totally fine. You just need a free USB plug somewhere because it doesn't even need Ethernet. It has Wi-Fi. So you can just plug it in anywhere. Like maybe you have a USB port spare on, I don't know, your router, your TV, something, right? You can just plug it in and it will connect to Wi-Fi and provide your service. And then the last ingredient here is using Tailscale. Tailscale is a mesh VPN, also written in Go. It runs just fine on Gokrazy. You can use it to make your service reachable over the internet. So it handles authentication and NAT traversal and all of that complicated stuff that is annoying to set up and maintain. I really like it. I use it on all of my servers and devices by now. All right, so to bring it back to supply chain, the kernel that goes into every Gokrazy instance, you can find it in this repository on GitHub, gokrazy/kernel. It is an auto-updated Linux upstream kernel. At most, like 24 hours after the release of a new Linux upstream version, our automation will have found that and tried to build it and try to automatically run the CI/CD pipeline and merge that new kernel. So if you update every day, you're always on a very fresh Linux version. The same concept for the Gokrazy firmware, which is just the Raspberry Pi firmware files. But then notably, all of Gokrazy is using Go modules. So all of the stuff I talked about actually applies to all of the Gokrazy programs. So if you use gokget, it just wraps go-get, right? So that's how you update. You can use go-vulcheck for your security analysis. You can use the replace directive to patch your code. All of that stuff just works. And then lastly, you use Gok update to update such an instance of Gokrazy remotely over the internet, over HTTP or HTTPS and or Tailscale. And you can just automate that from a cron job, run it every day, and ta-da, you'll have an automatically updating appliance. All right, so in conclusion, supply chain management can be tedious, but I think Go gives you great tools to really make it easy and doable. I would encourage you all to think about your supply chain and how you could make it any smaller or segment it somehow. And lastly, minimalist solutions like Gokrazy can help for select use cases. I showed you the Wake on LAN one. I'm actually like scanning documents with it. I'm running my home router on it. There's like a lot of stuff you can do you maybe wouldn't think. And that just makes me sleep better at night. And I hope the system can give you all some peace too. All right, so that's all I have. There's lots more details in the Go blog. If you're not following that already, please subscribe to it at go.dev/blog. Many people in the Go team also have their personal blogs. Russ Cox's blog is great. A couple of other members also have blogs. You can find more details about Gokrazy at gokrazy.org. And if you have any questions about it, just talk to me after the presentations. And then lastly, I would be happy if you could give me some feedback on how you found this presentation so I can improve in the future. So yeah, that's all I have. Thank you very much.